So now we're getting ready to get into the different alarm messages that you could encounter. All right, detector type, 5A or 5B, doesn't matter. Hot box defect. When they say hot box, they're talking about bearings on your wheels. All right, what's the action? As soon as you hear the word defect, you slow down to what? 30. Okay? You get off of the detector, then it will spill out the dope to you. Okay? Tell you what the defect is. After it does that, stop the train. Go back and you count to the indicated axle. Remember, you got to count axle by axle. 1, 2, 3, 4, all the way up to wherever it is. You go inspect that axle. Let's say it's axle 100. It's not hot. Okay? You're required, right here, to inspect 12 axles ahead of that and 12 axles behind that, if that axle wasn't hot. Let the dispatcher know what you find. And if you do have a defective car, do what you need to do to get it set out. Okay? So that's how you read the crew actions through your tables. And like I said, after a while on the railroad, you go over these detectors all the time, you'll know probably all this by heart. You won't have to have the book. Yes, sir.
When you set out cars, do you find like the nearest piece of siding and park it in there?
Yeah, you find the first place you can. That might be a siding. A lot of times we have what we call house tracks. They look like this. You know, the main line goes and goes and goes. You know, you might have a siding over there, and then 2 or 3 miles up, might have an industry over here, you know, for customers, you know, got his tracks and all that.
Are you able to put it in there?
Absolutely. You put it wherever you got to put it. Get it out of your train. Yeah. So if I got a hot box, and say I'm right here, right? If I got a hot bearing, that car is going right here. You know, that's just all there is to it. Because it's dangerous to keep going with it. Okay. But again, they may have house tracks. A house track is nothing but, we call them a stub track. It's just a piece of track that goes off here, and it might be 75 foot long, 100 foot long. And that's it. It stops. And that's where they might store like a piece of maintenance away track equipment sometimes. They're not using it, they'll just park it in there to get it out of the way. But you can use those too. Okay? So that's what we're going to do. And then any additional instructions you need to follow, go ahead and do that. So that was a hot box. You got the step-by-step instructions.
BNSF detector milepost 218.7. You have a defect. BNSF detector milepost 218.7. Hot box right side axle 21. BNSF detector milepost 218.7. Hot box right side axle 21. Total axles 242. BNSF detector out.
Any overheated equipment response requires you to stop the train and inspect the indicated axle as well as the 12 axles before and after. It's only necessary to inspect the side of the train indicated. If neither side of the train was specified, then both sides must be inspected. Remember, an accurate count is imperative.
So I hope you caught that. If they say axle 121 on the right side, that's the only thing you got to worry about. If they would just say axle 121 and don't give you a side, you got to inspect both sides. Okay. All right, 5A or 5B, you got a dragging equipment defect. What are you gonna do? As soon as you hear the message, slow down to 30, okay? When you get off the detector, are you with me? You get off the detector, it's gonna give you the information about the axle number. Stop the train. Go do your inspection. That means go to the indicated axle. If you don't see a defect, again, you're gonna inspect 12 ahead, 12 behind. Let the train dispatcher know what you come up with, and if need be, get rid of the car. Okay?
BNSF detector milepost 280.5. You have a defect. BNSF detector milepost 280.5. Dragging equipment near axle 3. BNSF detector milepost 280.5. Dragging equipment near axle 3. Total axles 1, 3, 6. BNSF detector out.
For a dragging equipment signal, you stop and inspect all around the car with the axle identified by the detector.
I was never that lucky as a conductor. My axles were always like 344 or 286. This is axle number 3 on the lead locomotive, right? All right, another defect, 5A or 5B, doesn't matter. Hot wheel. How do you think you can get a hot wheel?
Brake shoes.
Failed to take off the brakes. Or the air brakes on that one car's messed up and you got sticky brakes, right? And you have to cut the car out. Yes, sir.
What happens if you have a hot box on your motor or power?
If it's actually hot,
Yeah.
you got to get rid of the motor.
If it's the one that you're on?
If it's the one you're on, you got to get rid of it.
So what you do then, you just sit there with it?
That's right.
Okay.
Until they figure out something else. Remember, the onus is not on your back. Just sit up there, relax, and let them do what they're going to do. And that's happened before. All right, hot wheel. You get the message, you got a defect, slow down to less than 30. You get off the detector, get the information, stop the train. Go to the indicated axle. You still don't see a defect, 12 ahead, 12 behind. Report the findings to the dispatcher, and if you have to, set the car out.
BNSF detector milepost 306.7. You have a defect. BNSF detector milepost 306.7. Hot wheel near axle 4. BNSF detector milepost 306.7. Hot wheel near axle 4. Total axles 306. BNSF detector out.
For a hot wheel signal, you would once again stop the train and inspect the indicated axles, as well as the 12 axles before and after. If the message indicates the side of the train to check, you need only to check that side. If neither side was specified, then both sides of the train must be inspected. Again, an accurate count is imperative.
Is everybody kind of getting the feel for this? Yes, sir.
So actually in the train crew action segment,
Mm-hmm.
it says obviously slow the train down to 30 when you hear you have a defect. But, so are you saying at the end of the detector transmission, are you supposed to have that train stopped?
No, you're not going to. You don't have to have it stopped at the end. Okay. When you get off of the detector, it's going to give you the information. You already know you got a defect, right? So when you get off of the detector, just go ahead and start planning on stopping. But, I'm not saying it has to be so accurate that as soon as that rear car gets off, you got to be stopped. No. Now, having said that, I'll say this. You don't want to go
Like 4
Right,
miles.
right.
Okay.
You want to be stopped, you know, probably within a mile or a couple miles. All right, excessive alarms. What do you think that is?
Multiple defects.
Multiple defects. What kind of day you think you're having if you get this? Not very good, right? 5A or 5B, excessive alarms. What are you going to do? Well, as soon as you hear the words, slow down to 30. Get the information, stop the train. Go to the indicated axles. Now there's a little bit difference right here, okay? Here's what I'm going to do. With excessive alarms or multiple defects, let's say it gives me axle 20, axle 40, and axle 60, just for kicks and grins, okay? What I'm going to do is I'm going to walk back to axle 20. It's not hot. I go 12 ahead, 12 behind, right? Then I go to axle 40. It's not hot. 12 ahead, 12 behind. I go to axle 60. It's not hot. I go 12 ahead, and then for the remainder, I have to walk the whole train. All the way to the rear, back up around the other side, back up to axle 60. Okay? When I get to the last axle they mention, I have to walk the rest of the train. Back around up to that last axle. Both sides, remainder of the train, yep. Let the dispatcher know what you find, and if you need to set a car out, do that. All right, here's another little note. Right here. You're going over a 5A or a 5B detector, doesn't matter. And then you get the message that says, hot box, train too slow. But it doesn't give you any information, right? It doesn't give you any information in this because the train was going too slow to make an accurate, precise inspection. But it sensed probably that one bearing was quite a bit different than the others, so it just spit out that term, hot box. In the event that it does that, this is what you got to do. You got to stop and walk both sides of the train and look for it. Okay?
BNSF detector milepost 342.5. You have a defect. 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 BNSF detector milepost 342.5. First hot box, left side, axle 2, 4. Second hot box, right side, axle 4, 5. Third hot box, left side, axle 6, 8. Fourth hot journal, left side, axle 7, 5. Excessive alarms, BNSF detector milepost 342.5. First hot box.
By this time, I'm in the cab like, give it to me already.
4. Second hot box, right side, axle 4, 5. Third hot box, left side, axle 6, 8. Fourth hot journal, left side, axle 7, 5. Excessive alarms, total axles 1, 6, 8. BNSF detector out.
When an excessive alarms message is received, you must stop the train and inspect the indicated alarms and then inspect from the last recorded alarm, in this case, left side 75, to the end of the train. Your inspection must include both sides of the train.
Okay, understand that?
Why do you wrap around the back end of the train and check?
Because if they give you excessive alarms, it's basically saying you got so much wrong with your train that we're just not gonna take any chances with the rest of it. Okay?
It's got a short train.
Huh?
At least it was a short train.
Yeah. That's right. And let me tell you something also. Normally, if you have a true hot bearing, there's not much guesswork involved. Meaning, you can smell it. You can, that grease gets hot in there and stuff. You can certainly feel the heat radiating off of that wheel. All right, so it's pretty easy to tell. I mean, you don't have to sit there for 20 minutes and, is it really hot? You'll know. Plus, we got other ways to make sure that it's legitimate. All right, other circumstances you may encounter. 5A or a 5B. Speed varies by more than 10 miles an hour from your actual speed. So you go over a detector, a lot of times these detectors give you lots of information. It might say something like, detector milepost 185, no defects. Axle count, 180. Train speed, 62. Temperature, 58. Gives you a lot of information. All right. Now, if that train speed that detector gives you is more than 10 miles an hour variance in what you're showing on your speedometer, you have to stop and make a walking inspection both sides of the train. So let's say I'm going 45. That's what my speedometer says. I go over this detector and it says I'm going 60 over the radio. That's more than 10 miles an hour difference, right? I have to stop my train and do a walking inspection. Why do you think that is?
10% Glen's job.
We don't know, do we? Is the detector messed up? Or is my speedometer messed up? Right? So we don't really know. It's one or the other. So what we're going to do is we're going to err on the side of safety and say, well, what if it is the detector? If it's messed up on the speedometer, it might be missing something on an inspection too. You see what I'm saying? That's why they make you stop and walk the train and inspect it, just in case it is the detector that's malfunctioning. Okay?
There are several instances when you must stop and perform a walking inspection of your train. They are, if the message is garbled or incomplete, if an inaccurate axle count is given, a train speed variance of more than 10 miles per hour between actual train speed and the speed when announced by the detector. If your train has a caboose with a generator attached to the axle indicated by the detector, the caboose does not have to be set out if no other defect is found. If you get an incomplete message or no message, you must request the recall of the detector message per special instructions. If you receive a warning and find no defects or indications of overheated equipment, the train may proceed, but crew members must observe the equipment for the next 25 miles or until the next hot bearing detector has inspected the train.
So our timetable tells us where these detectors are. It tells us what kind they are, what they look for, all this stuff. They also have on there, and I'm sure you probably saw it, a recall code. associated with some of these detectors. So if you go over the detector, it gives you the information and you didn't get it all the way for some reason. There's a recall code you can push on your radio number panel, and it'll repeat the message for you. And your timetable tells you what that recall code is, if there's one associated with it. All right, train inspection. Let's see what's on here that you need. All this is telling you here is when the detector inspects your train, it's literal. It's literal from the way you go over it, right? If my detector's here and I'm going this way, this is my first axle, right? And the direction I'm going, this is the right, this is the left. See what I'm saying? So it's literal by how the cars go over. Now, obviously, if you're rolling down the railroad track at 70 miles an hour, hopefully the locomotive's in the lead, right? But it is possible to be backing down for whatever reasons. So you got 20 cars, you're on a local job, and you're shoving for a few miles, right? Well, if I'm shoving, the first axle is still the first axle. It's just on a car, right? And it's still on the right side or left side. So that's how they determine direction. Okay. Dragging equipment. All right. Go to this one in your book. Here's what this is saying. If I get a dragging equipment defect, axle 300, I get off my train, I start walking back, counting axles. I get to axle 100, and now all of a sudden here's a bridge. The rest of my train's hanging over the bridge, right? And that bridge doesn't have a walkway for me to get back there. I am authorized to pull my train forward at no more than 5 miles an hour to clear up that situation. Okay?
BNSF detector milepost 325.3. You have a defect. BNSF detector milepost 325.3. Hot box, left side, axle 160. BNSF detector milepost 325.3. Hot box, left side, axle 160. Temperature 76 degrees. Total axles 200. Detector out.
Train 143 was behind schedule and just hours from home when they heard this warning. The same warning they'd heard from the previous detector. Once again, the engineer stops the train and the conductor starts at the head end of the train counting axles.
BN 6745 West calling conductor sent over. Says the conductor swim over. We got a hot shot behind us and the dispatcher needs a track. We need to get moving. BN 6745 out.
Darn it. Lost my count. Let's see. We have 200 axles. I'll just walk to the rear of the train, count back 40 axles. That'll take me 900.
Finding no evidence of overheating, the conductor makes what he thinks is the safest decision. He sets out the car with the 40th axle. The train continues on its way.
BN 6745 West calling Fort Worth dispatcher over.
BNSF Fort Worth dispatcher over.
We got 12 cars derailed at milepost 212 over.
What did the conductor do wrong? It is arithmetic. For example, if you have a train with 12 axles and the detector says check axle 8, counting from the head end of the train, you easily find axle number 8. But you can't count the same way from the rear end of the train, because what you think is axle 8 is really axle 9, and the wrong car will be set out. The result? Derailment. Costly in equipment, costly in materials, but more importantly, a possible cost in lives. actually where most errors occur. So we're going to give you some tips on how to keep an accurate axle count. To determine which side of the train is the left or right side, face the direction the train is moving. Your left is the train's left. To find the specified axle, always start counting at the lead axle on the lead locomotive in the consist and count each axle as you walk towards the rear end of the train.
Here are some more tips on how to keep a secure axle count. Bring along a pencil, a piece of paper, or the wheel report, and perform a car-by-car inventory of the axle count, documenting the number of axles for each car. Even if you have a car-specific axle count on the wheel report, a car might have been set out, added, or rearranged. Never assume the wheel report is accurate.
Another method is to use a mechanical device such as a tie counter to help you keep track of the axle count.
That is a huge deal. Meaning, you cannot rely on your train list for your axle count information. I told you that your train list has an axle count on it for you. That's the way it is. And it also has a cumulative axle count, meaning it'll have the total axles of the train, and then it counts each car's axles for you right down a column. So my first car, if I got 2 6-axle locomotives, that would be 12 axles. When I get to my first car, I look all the way across and it'll say cumulative axle count. And I'll have 16 axles because I got 12 on my locomotives. And in each car, if it's got 4 axles, it's going to add 4. You see what I'm saying? So if I get axle 60 on a defect, some people want to kind of get ahead of the game, and while the train's coming to a stop, they'll get their train list. They'll say axle 60. Okay, and I'm looking at my train list. Axle, okay, 48. Okay, 60. Axle 60. Right. Then they'll look to the left, and they'll see this car number. You see what I'm saying? So they'll get off and just start walking to that car number. You can't do that because your list could be wrong. You see what I'm saying? Could be missing a car. You could have an extra car. You might have cars flip-flopped. Anything. Okay? So you cannot depend on your train list to get your axle. You've got to physically count them. Testing the bearing temperature. Like I said, a lot of times if it's hot, you'll know it. Okay? But just to be sure, the railroad provides you with a way to determine if it's hot or not. On the UP, we used to call them temp sticks. It's kind of like a crayon. Okay, and you mark the side of the journal, the bearing. If it melts the crayon, it's hot. If it doesn't melt it, it's not hot. That's the way it works. Okay. That's kind of how it works. And mark it right there on the side. If that mark melts, it's hot. Here's what can happen to a bearing that's really overheated. And some of these things can get so hot that they will glow red and just fall apart. Okay, that's how hot they can get. Right here. The hot bearing that fell apart. All the truck bolsters come apart, and you're talking about a serious derailment right there.
Failed equipment detectors check the temperature of each bearing as it passes over the detector, using ambient temperature as a reference and measuring for high or abnormal temperatures. For example, if the outside temperature is 90 degrees, the detector is looking for any bearing temperature which exceeds 258 degrees. If the ambient temperature is 20 degrees below zero, the detector will be looking for any bearing temperature which exceeds 148 degrees. These excessive temperatures are why we use wax crayons to find the defective journals. Outside temperatures will determine which of the 2 types of crayons you should use. If the ambient temperature is above 32 degrees, use the 200 degree crayon. If it is below 32 degrees, use the 163 degree crayon. Once you've located the indicated axle, Rub the end of the crayon on the end cap of the journal, looking for signs of melting in the crayon. Remember, only use the 163-degree crayon if the air temperature is below 32 degrees. And never use your bare hands to do a temperature check on wheels or journals. If the crayon melts or there's anything suspicious, like grease around the plate of the wheel or bluing of any of the wheel or journal components, set the car out.
An X and the date must be written above each journal indicated or found to be overheated. For overheated and indicated wheels, mark a W and the date above each one. If it took you an unusually long time to get to the axle, and it has had time to cool, check to see if the journal is radiating more heat than the journals around it. If it is, don't take any chances. Set the car out. If you get to the axle and find that it's not overheated, check 12 axles in front and 12 axles behind the axle in question. Once you've determined which car is to be set out, immediately write down the car number, the journal size, and the wheel or journal location on the car. All of this information must be given to the dispatcher, as well as written into the bad order report. Journals come in a variety of sizes. It's important to correctly identify the proper size of the bearing, so that the mechanical department will bring the proper replacement journal when they come to make repairs. Specifying the exact location of the failed bearing is just as important as identifying the correct size, because if the mechanical department changes the wrong bearing, a derailment could occur when that car is put back into service.
Here are a few tips to help you clearly indicate which bearing is to be replaced. For a conventional single platform car, start counting at the end of the car where the handbrake is located. Facing the handbrake, your left is the car's left. For cars with handbrakes on both ends or multi-platform cars, locate the B stencil. Count from the B stencil. Facing the B end, your left is the car's left. Remember, when counting axles on multi-platform cars, the 10th axle is identified as axle Z, the 11th is Y, and the 12th is X. For a locomotive, the numbering is slightly different. The axles are counted from front, the end with the F stenciled on it, to back. Standing with your back to the front of the locomotive, your left is the locomotive's left. Don't take chances when setting out a car. Watch the car closely to be sure the journal doesn't burn off before you get the car safely positioned. If damage is extensive enough, you may have to hold the train where it is until mechanical can change out the wheel.
Place the car where it will be easily accessible for the mechanical department to make repairs. They're going to have to jack the car up, so solid level ground is essential. Remember, all the information you've recorded, car number, journal size, and journal location, need to be given to the dispatcher as well as indicated on the appropriate form. This information needs to be turned in or faxed upon completion of your trip or tour of duty.
One thing they said that really stands out, I mean, I think you know how to count axles and all that. That's good information. But one thing they said that stands out, or it should stand out, is if you do, in fact, have a hot bearing, you have to set that car out. But sometimes you have to move your train a mile or a couple miles down the track until you find somewhere to put it, right? You have to make a determination as a conductor, looking at that bearing in that car, and see if it's even safe to move. It could be so hot and so defective, it might not be safe to even move the car at all, because it could fall apart, right? If you feel that it's not safe to move the car, don't move it. Just sit right there where your whole train and tell them to call somebody to get over there and look at it. Okay? Because if you move the car and everything falls apart, they're going to get you for that. Okay? Because you decided to move it. Railroad has all the parts they need and all the machines they need. They can change those wheels out right there where you sit, if they have to. They don't want to, but they can. Okay? So make that decision. Consecutive alarms, good one to look at here. If you have a hot bearing defect, you walk back and you check it and it's not hot, then you keep going, right? Unless it was on a key train. The very next detector you get to, if it gives you that same axle, same side as being hot, and you go back and check it and it's not hot, it doesn't matter at that point. You have to set the car out because it hit you twice with the same axle. Okay? Locomotive. All right, 8H. Hot bearing is found within 25 miles of a trackside warning detector equipment. The crew must notify the train dispatcher. Here's what they're saying here. Let's say you're going down through there. You go over a detector. It says no defects, right? And let's say 20 miles later, you go into emergency. It just happened to, something happened and you went into emergency. And the train stopped. Well, you have to walk your train and inspect it when you go into emergency. So you're walking your train, inspecting it, and lo and behold, you walk by this car and you're like, wow, that feels hot, you know? And then you get to investigating and you got a hot bearing on a car. They want you to immediately know tell the dispatcher that information. Because it could be this detector that you went over 20 miles ago could be defective and not picking up the defects. Okay? Another one to remember, right here. Blowing or swirling snow conditions, it could prevent that detector from giving you a very good inspection. Okay? So to minimize that, during those conditions, they want you to slow down to 30 to go over the detector so it has time to look at your train.
When a detector message requires you to stop your train for inspection, stop the train as soon as possible, most certainly within 2 miles of receiving the failed equipment indication. Remember to minimize in-train forces and slack action when applying brakes. Detectors also have a minimum heat requirement to begin analysis. If a train has been stopped for any length of time close to a detector, the bearings can sometimes cool so much that they won't trigger the detector sensors when the train passes. This can result in an integrity failure response from a failed equipment detector.
Blowing or swirling snow from a passing train can interfere with the detector's ability to properly scan the train. When these conditions exist, reduce train speed to no more than 30 miles per hour to minimize this condition. Under extreme conditions, such as when the train is stopped on a bridge with no walkway, in deeper drifting snow or high water, the train may be moved at a speed no more than 5 miles per hour until a safe location has been reached to complete the inspection. If overheating or a defect on the same equipment is indicated by 2 consecutive hot bearing detectors, the identified equipment must be set out of the train.
So back to this, if you have to inspect your entire train and it just so happens to be at night, do you use a flashlight or just do you try the best possible robot you can perform, or is there
No.
some specific?
You're
thing?
talking about for any reason if you have to walk your train at night?
Well, no, yeah, if you have to stop after the detector tells you to
Okay.
inspect your entire train and it's at night, and you don't, there's no good way of seeing
You carry your lantern,
okay.
and that's all you have available to you. Yeah, your lantern. But those, you get pretty good light off those if you got a good battery on them. High water detectors. Just a little bit about high water detectors. Obviously, they protect the railroad from a creek or a river getting out of its banks and then possibly washing the railroad tracks out over the, the bridge. And the way a high water detector works is, let's say you got, that's the creek or the river. That's the railroad track going across. They will have a detector, a high water detector, at the creek. Okay? If the water level gets up high enough to trip this detector is also in sync with a signal. So if it trips the detector, and it's also going this way too, by the way. So it trips these signals red, right? Now, when I come by here, this signal is red. What do I do with my train? This is a signal pop quiz. Proceed at restricted speed. Okay, why? It's got a number plate. So I'm at restricted speed, so there should be no reason why I get here, find out the bridge is gone, and go off into the creek, right? Because I was prepared for that. I was at restricted speed. That's how the high water detectors work. And that's why I tell you, don't get complacent about these restricted signals out there, because you never know when it's the real deal. Something really bad wrong. Okay? Treat every one of them the same. You don't know what's going on.
So if you can't see the tracks, you don't go over them?
Right. If you got up to this and you're like, dang, that water's like a foot over the tracks, I don't even see the bridge, you definitely don't try to go over it. Just make a call and do what? Click that. Try it.
In the winter when it's snowing and you can't see the track, do you just go over it?
Yeah. Especially if you're on the main line, because those locomotives, let me say yes and no. And here's why I'm going to say that. You got to be really careful. If, let's say you're making a shoving move, right? And you have an empty car that you're shoving. And it's going over ice or snow that's covering the rails. What these empty cars can do, if you don't watch it, they can start packing that snow down on top of the rail. And you know what happens when snow gets packed? It gets pretty strong and hard, don't it? So you could start packing that snow, and all of a sudden, those wheels will be riding on snow and not rail. You see what I'm saying? That's the danger with empty cars. So you want to watch that. You may not want to do it. With a locomotive, completely different. If your locomotive's leading the way, it weighs 200 tons. Okay? There ain't nothing going to be on that rail when it gets done. You see what I'm saying? It's going to disintegrate everything. So, yeah, we went out training here at Lenexa Yard with a class one time. We had most of the yard had 2 feet of snow over the tracks. And there were some places that had 3 feet, you know, because of drifts. And we took the locomotives and just ran, and it just, you know, got rid of the snow. Now the snow all around us was still knee deep. It was hard to get around, but it wasn't a derailment problem, you know. Slide detectors, rock slides. You know, I don't know if you've seen any of those out in kind of mountainous cliff territories that looks like chicken wire. They operate with signals just like high water detectors. Rocks or something hit that, it senses it, throws a signal red. Form journals, don't care about. Track integrity, don't care about.
There's one last thing. It's very important that any and all detector information be relayed between crew members at crew change points. Failed equipment detectors serve a very important purpose. They help you to perform your job safely. It's your responsibility to understand their messages and properly carry out their instructions. Don't take them for granted.
Questions on trackside warning detectors. It's pretty straightforward. Like I said, being new to the railroad, you'll probably have to bury your face in that book quite a bit, you know, but over time you'll get used to it and it won't take long. It's just like anything else. It'd be second nature to you.